140 million miles away, in the middle of a frozen Martian desert, a car-sized robot just did something that was once considered impossible. For nearly 28 years, we have treated our Mars rovers like high-stakes RC cars, with human engineers meticulously clicking every single waypoint from an office in California. But on December 8, 2025, that all changed. NASA just handed the keys to a generative AI, and for the first time in history, a machine planned its own journey across the surface of the red planet. This isn't just a software update, it is a fundamental shift in how we explore the cosmos. Today, we're looking at how AI just took control of the Perseverance rover and why the old way of exploring space is officially dead. To understand the weight of this moment, we have to look at the Perseverance rover, also known as Percy. This six-wheeled robotic scientist is currently stationed in the Jezero crater, a massive impact basin on Mars that was once home to an ancient river delta. Perseverance isn't just there to take photos, it exists to search for signs of ancient microbial life and collect rock samples that could one day be returned to Earth. It is the most advanced mobile laboratory ever built, but it faces one massive obstacle. The environment it calls home is one of the most hostile and unpredictable places in the solar system. Before this, engineers had to manually plan every route, carefully studying images and sending step-by-step instructions. For almost 3 decades, human drivers at the Jet Propulsion Laboratory, or JPL, spent hours analyzing terrain data to sketch out routes using waypoints, fixed coordinates the rover must hit in sequence. These waypoints were typically spaced no more than 330 feet or 100 meters apart to ensure the rover didn't get stuck or damaged. Driving on Mars is extremely hard because commands from Earth take up to 20 minutes to reach the rover. That means humans can't control it in real time. If the rover encounters a field of jagged rocks or a steep sand ripple, it has to stop and wait for a human on Earth, millions of miles away, to decide the next move. This manual process is slow and labor-intensive, severely limiting how far a rover can travel in a single day. Now, for the first time, NASA used artificial intelligence to help plan the rover's driving routes on Mars. In a landmark demonstration led by JPL in collaboration with the AI company Anthropic, NASA utilized Claude AI models to automate the complex decision-making tasks that used to take human teams hours to complete. For the first time, a vision-capable AI was able to create a safe, continuous route over the Martian surface without any manual input from human planners. The AI looks at images of the Martian surface, identifies dangerous areas like rocks and slopes, and then suggests a safe path for the rover to follow. Specifically, the team utilized vision language models that were granted access to the mission's vast dataset. This included high-resolution orbital imagery from the HiRISE camera on the Mars Reconnaissance Orbiter and digital elevation models that represent the terrain's height and slope.
If you enjoy deep-dive science documentaries like this, focused on real data, real mysteries, and the edges of human knowledge, consider subscribing. New videos explore the universe where certainty ends and discovery begins. And let us know in the comments what you think. Thanks for watching.
By analyzing this data, the AI could distinguish between safe bedrock and hazardous features like boulder fields, outcrops, and sand ripples. It then generated a continuous path filled with its own navigation waypoints. To ensure safety, NASA scientists first tested these AI-generated commands on a digital twin, a virtual replica of Perseverance, where they verified over 500,000 telemetry variables before ever beaming the instructions to Mars. Using these AI-planned routes, Perseverance successfully drove hundreds of meters without any problems. Over the course of 2 days in December 2025, the rover put the AI's logic to the ultimate test. On December 8th, with the AI-generated waypoints in its memory, Perseverance traveled 689 feet, 210 meters. Just 2 days later, on December 10th, it completed an even longer drive of 807 feet, 246 meters, along the rim of the Jezero crater. In total, the rover covered nearly 1,500 feet, 456 meters, using paths created by the generative AI. Annotated images from the mission show a magenta line representing the AI's plan and an orange line showing the actual route taken, revealing how precisely the rover followed the AI's logic. This could allow future space missions to explore faster, travel farther, and rely less on constant human control. This breakthrough streamlines the pillars of autonomous navigation: perception, localization, and planning. According to JPL roboticist Vandy Verma, we are moving toward a future where rovers can handle kilometer-scale drives on their own, allowing human scientists to focus on the science return rather than just the steering. Bigger picture thinking suggests these intelligent systems won't just stay on Mars. NASA's leadership, including Administrator Jared Isaacman, believes this technology will be integrated into helicopters, drones, and edge applications on the Moon and beyond. This is the game-changing technology necessary to build the infrastructure for a permanent human presence on the Moon and eventually take the United States to Mars. We are living in an era where AI is no longer just a tool for writing emails or generating art. It is now the navigator for our most important missions into the unknown. The success of Perseverance's AI-driven mission proves that we are ready to explore the solar system faster and more responsibly than ever before. But what do you think? Are you ready to trust AI to lead the way for human astronauts on Mars? Let me know your thoughts in the comments below. If you want to stay on the cutting edge of space exploration and AI technology, hit that subscribe button and turn on notifications. Every discovery brings us one step closer to the stars. Thanks for watching, and we'll see you in the next one.